are going to learn about the growth models. There are two different types of growth which will help you to find out the population rate. Okay, there are two different types of growth models. One you're going to learn is about exponential growth curve, and the next one you're going to learn about the logistic growth curve. So what is a curve? You're going to represent with the help of the graph. Okay, again I have told you, again I'm insisting you, in this chapter ecology you have more number of graphs where it is very important for your board exam. Very, very important. So please give a more importance for these graphs. You have to be thorough with all the graph concepts of all the graph. Okay, right? So here also you are going to learn about two different type of graph, okay, which will explain about the exponential growth, and next one is about the logistic. Okay, right. Now what do you mean by the term exponential growth? Okay, so first one is about exponential growth. Okay, so the number of individuals born, if there is a number in the population, increase in number, then you call it as birth rate. Okay, if there is a decrease in number, then you call it as death rate. Okay, so birth, I told you, natality is mentioned with the term of, what is that, small p. And mortality is mentioned by death rate, t, small t. Can you understand? So by that terms are very, very important. Okay, so natality, don't forget, natality is what? Birth rate is given in the form of B, and mortality is death rate in the form of T. Okay, right. Now when you learn about this, what is an exponential growth curve, it talks about where the resources are unlimited. What are the resources? Tell me. All the favorable conditions, right? Whether what is that, food or shelter or space or whatever it is, whatever needed for the development of the individual, you call them to be resources. What about the resources what we use? What are the natural resources what we use? Everything: air, water, temperature, pressure, coal, petroleum, food, oil, everything. All these are natural resources. Is it not? Okay, that is what we are learning here. We have the relationship between the what is that, abiotic environment. Okay, so the relationship between the biotic and the abiotic environment. Okay, the relationship between the biotic and the abiotic environment. Okay, so what is that relationship? So biotic factors cannot survive without the interaction of the what is that, abiotic environment. You need air, temperature, water, pressure, everything. Light, everything is needed to survive. Is it not? Okay, so only when the resources are available, or only when there are a favorable condition, an organism can survive. Is it not? Okay, the same way, when you talk about a population, you're talking about the group of individuals of same species, what are to do. Okay, so if the resources are unlimited, what is that unlimited? It is excess. It is more. It is more in number than the population. Can you understand? Listen, the number of individuals in a population, can you understand? You know that what is the number. So that is nothing but group of individuals, you call it as a population. Other than the population, okay, just example I'll tell you. If this is the population group of individuals, okay. Other than this population, the resources are more. Water, what is that? The food, the shelter, space, air, everything. All the resources are unlimited. Than the population size, the resources are more. They are unlimited. One more thing, this is mainly done in the laboratory. It does not occur naturally. Okay, so we can mention simply as it is not a naturally occurring process. So this type of what is that condition can be given in the laboratory. Okay, when it is done artificially. So it is not a naturally occurring process. Can you understand? Okay. Now when you talk about the population, okay, so they can make all the resources. That is what we have done. What is a population? Group of individuals of same species where they share and compete. What is sharing? I told you, when the resources are more, you are going to share it. When the resources are less, imagine if this is a population and the resources are going to be less than the population, then you are going to fight between them. Is it not? Okay, so they will compete for the natural resources. What I told you, in this condition, the resources are unlimited. So they are going to share. There is no competition among them. Okay, so the organisms are reproducing to their maximum capacity. There is no problem at all. Okay, when I draw the graph here, can you see it? Okay, this here graph is being plotted against time t and the population density. That is what here we are learning. Population density. So what is population density? It is measured in terms of n. Yesterday I had taught you, right? Time is t. Okay. Now when you plot a graph, you can see that there is a what is the growth in the population because the resources are unlimited. The organism starts reproducing to their maximum capacity because all the resources are available. Nothing in shortage. Can you understand? So what happens when you plot a graph against T and density? The population goes on increasing. Okay, it increases more and more and more. So when you draw a graph, the graph, you can see this graph, it increases here at the starting stage when the time, according to the time, when the time increases, the population density also increases, but here it is very slow. But at a certain stage, when it comes to understand that the resources are unlimited, okay, it has sufficient, everything is sufficient for them. So they start reproducing on their own and they develop towards a maximum capacity. So it grows and grows again still. Okay, so this type of growth curve is seen. So this is called as J-shaped curve. So what is the shape of the exponential growth curve? J-shape. So the formula when you just calculate against time t, okay, against time t, the population density or the population size is calculated in terms of n. You would have learned in math students, you will understand. To find increase or decrease in population. So to find increase or decrease in the population, okay, so this t and the n, it can be calculated in the form of differential calculus dn by dt. Okay, so when they calculate, the formula what is given here is dn by dt is equal to, okay, Rn or dn by dt is equal to b minus t into n. What is this b minus t? Birth rate minus death rate. This is the formula you have to learn. That's it. Okay, all this derivation I think you'll be learning in neat portions. Can you understand? So birth per capita, I told you again, birth rate per capita per individual, okay, is B. Likewise, death rate per individual is T. So when you calculate the increase or decrease in the population in the form of calculus, okay, dn by dt is equal to B minus D into N. So what is that B minus D? Birth rate minus death rate. So this will give you the natural increase. So this B minus D, okay, it can be calculated in the form of R. So what is R? R is nothing but rate of natural increase. Or dn by dt is equal to Rn. The resources are unlimited, can be done in the laboratory condition. This type of growth curve can be observed in the laboratory condition, okay, where the what is that? Where it does not occur naturally. Whereas the other growth curve, the logistic growth curve, what you are going to learn, it occurs naturally. That is the main difference what you are going to learn. Okay, and here the resources are unlimited. Whereas when you learn a logistic growth curve, there the resources are limited. Be clear with the concept. Okay, so when the resources are unlimited, what happens? Here, when you're going to plot a graph against time t and the population density, I told you the population density is measured in terms of n. Population size is measured in terms of n. Right? Okay. And this time t, according to time t, you're going to calculate whether there is an increase in population or decrease in population. So that can be measured. So when the time increases, what happens here? The population growth also increases. Why? Because the only main thing is resources are unlimited. There is no restriction. There is no competition. Okay, so the growth goes on increasing. So this type of growth curve is observed in this type of what is a population. Then you call this as exponential growth curve. So this was observed by a person called as Charles Darwin. Okay, who is Charles Darwin? Origin of species, survival of the fittest. Would have learned the concept, right? Okay. So he was a person who also accepted this exponential growth curve. And this curve is otherwise called as J-shaped curve, and it is given by the what is that calculus representation dn by dt is equal to b minus d into n, whereas b minus d will give you the rate of natural increase. So r, so dn by dt is equal to rn. Relation from dn by dt is equal to b minus d into n. From that you will get an equation n t is equal to okay n0 e power rt. This is the mathematical expression of exponential growth curve. Mathematical expression of exponential growth curve. Okay, actually there is a derivation. How this, what is the equation is being derived from dn by dt is equal to Rn. Okay, right? That one you'll be learning in detail in your mid portion, right? Okay, so just to know that what is the mathematical expression given here is M T. M T is the population density calculated against the time. Okay, so M0 will be the initial population. N0 starting initial, right? And then E power RT. Okay, so E will be the log value. Can you understand? Now, what is MT? I told you population growth after time. Okay, which is calculated against time. Can you understand? Okay, after time or against time. Now, M0 will give you the initial population. E will give you the log value. Always E you would have studied in logarithm, is it not? Which will give you the log value. Okay. And what is R? Just now I told you B minus T is equal to R. What is R? Intrinsic rate of natural increase or natural rise in population. Anyway, natural rise or in your textbook it should be given as intrinsic rate of natural increase. So B minus D will give you the increase in the rate R. Okay. And what is T? Time is the T is the time period. Okay. So this.
Thank you.